Buenas Day. My name is Alyssa Bersamin, and I'm here along with my team members Kristofer Cruz and Villiame Vuetibau. We are civil engineering students representing the University of Guam, and we will be presenting our senior capstone project, the design of the Guam Community College Trades Facility at the Simon Sanchez High School Structural Considerations. Simon Sanchez High School was initially built in 1974. For nearly 50 years in service, the campus has managed to fulfill its purposes in providing a proper educational environment for students, faculty, and staff. However, due to factors such as Guam's prevailing weather conditions and maintenance issues over the years, the structural integrity of the building has been compromised. As a result, the school is in the works of updating its civil infrastructures, which include the proposed construction of the Guam Community College Trades Facility. Based on the architectural plans provided by TRMA, the proposed GCC facility will consist of a one-story split-level structure composed of offices, classrooms, and workshops that shall accommodate for the GCC program curriculum. At this time, the objectives of this project will merely reflect our preliminary findings since our project is an ongoing project. Therefore, in these beginning stages, our objectives are to review and analyze the architectural plans, investigate the structural components of the design requirements, decide on 3 potential framing systems based on our findings, and finally, draft the 3 conceptual designs.
Methodology. Our methods in completing our project are seen in 5 different areas: conceptual structural design, cost-benefit analysis, in-depth structural design, iterative design, and final draft drawings. In conceptual structural design, we review architectural plans, we decide appropriate location of our structural members, we select the preliminary framing of our system, then draw these systems. In cost-benefit analysis, we produce preliminary cost estimate, identify known benefits, and recommend maintenance and sustainable efforts to help reduce the cost. In-depth structural design is where we identify load paths, select appropriate design codes and specification to identify load effects, calculate these load effects. Iterative design. In this phase, we generate a model to perform calculations. And this model is based on our calculating strategy in our class CE 306 by Dr. Hong. Finally, we will produce a final draft drawing where we fine-tune the designs and provide detailed drawings using AutoCAD.
To begin creating conceptual designs, our team conducted a design workshop in which we reviewed the architectural plans and designs with our industry mentor. We began by first familiarizing ourselves with the layout and general use of the building. After familiarizing ourselves with the architectural plans, we began formulating design constraints that would govern our conceptual designs. The building has large windows and doors closely spaced together, which may affect the load-carrying capacity of the walls. A framing design using columns would help eliminate the concerns of large windows and doors. However, it may limit the versatility of the different sections of the building for future addition or elimination of other vocational training classes. The building structural design should accommodate the relocation, addition of heavy equipment needed for the vocational training classes. Using the information from the design workshop, we were able to come up with these 3 conceptual designs. Preliminary framing design 1 consists of a cast-in-place concrete roof supported by reinforced concrete beams. The reinforced concrete beams will be supported by reinforced concrete masonry unit, burying and shear walls along the interior and exterior perimeter of the building. Preliminary framing design 2 consists of a precast, pre-stressed double T concrete roof with a reinforced concrete topping. The precast, pre-stressed double T roof will be supported by a cast-in-place reinforced concrete bearing and shear walls along the interior and exterior perimeter of the building. Preliminary framing design 3 consists of an open steel web joist and composite metal deck roof with a reinforced concrete topping. This will be supported by precast, pre-stressed concrete panel bearing and shear walls along the interior and exterior perimeter of the building. For all three conceptual designs, the walls will tie into a reinforced concrete shallow continuous foundation. The floor slab will be a reinforced concrete slab on grade that will also tie into the shallow foundation and walls.
Thus far, we have produced 3 conceptual designs to be considered. These designs will be further deduced upon research and analysis and compared in a cost-benefit analysis that shall be conducted in the near future.
Future work and recommendations. Structural analysis and design. Our load considerations shall be in accordance with IBC 2018 and ASCE 7-16. In this part of our project, we will design the structural members of the structure, such as the beams, compression members, and foundation. Our model, which is based on our calculation exercises in CEE 306, reinforced concrete structures, shall be used in calculating the dimensions of these said structural members. Our group will provide a cost estimate of materials by gathering unit rates and prices. In this analysis, we will compare the social, economic, and environmental factors of each of the 3 designs presented. Moreover, we will focus on ways on how to prolong the service life of the structure. For example, several school buildings owned by GDOE have cracks and spalling issues on the roof and beams. It was investigated that ponding on the roof has been the problem causing these significant structural deterioration. As a result, our group will focus on how to prevent these types of problems to sustain the life of the structure. All of these will be discussed in the sustainability part of the project, where our group will recommend maintenance procedures and frequency, and possible civil design changes, where an example, an increase of pipe diameter or increase of drainage outlets shall be proposed, along with the maintenance procedure and frequency to solve potential water ponding on the structure's roof.
To conclude our presentation, we would also like to thank and acknowledge our industry advisor, Mr. Thomas Camacho of Duenas Camacho and Associates, and our 2 capstone advisors, Dr. Ernesto Guades and Dr. Pyo-Yoon. We would also like to thank you all for giving us this opportunity to present our project, and we hope you enjoyed.